Hey everybody, today we are going to continue doing the next problem from LeetCode's problem list called Top Interview 150. Here I have that page open. We have already done the first three problems, and if you have seen the videos, you will realize that the second and the third problem were very similar in the core approach, and looks like the fourth problem might be something similar. But anyway, let's take a look what that fourth problem is. Remove duplicates from sorted array 2. So here in the previous video we did remove duplicates from sorted array. This one looks like a slightly different version of that. Given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Okay, so looks like the main difference between remove duplicates from sorted array and this version of the problem is that we are allowed to keep two duplicates and not more. In the other version, we were not allowed to keep any duplicates and we were supposed to remove them in place. Since it is impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of num should hold the final result. It does not matter what you leave beyond the first k elements. Yeah, this is similar to the last two problems, and if you haven't seen those videos, what they are talking about is after removing duplicates in place, the first k elements will contain the answer and the remaining array elements can just have any random values and it doesn't matter what values they hold. And then of course after everything is done we have to return k because the array dot length, for example in Java, won't really give the correct number of elements because that would be the longer length before removing duplicates. So we have to return the new logical length of the array. Do not allocate extra space for another array. You must do this by modifying the input array in place with one extra memory. Yeah, that is fine. We took an approach which was of one extra memory in the last two problems. This problem is very similar with a slightly different condition that we'll need in the details of the algorithm. Anyway, they have given judge code which will actually execute our code and test whether our code works or not. And let's look at a couple of examples, although it does seem straightforward. So 1, 1, 1, 2, 2, 3 here, there are 3 ones, so we are allowed to keep maximum 2. So it will be 1, 1, 2, 2, 3, and the last cell can contain any random value. Even 3 is fine, 1 is fine, whatever, it doesn't matter. 0, 0, 1, 1, 1, 1, 2, 3, 3. So I think the 4 ones become 2 ones, but everything else stays. Yeah, the last two again, the last two cells of the array can have any value. Okay, the restrictions, yeah, the size of the array seems to be between 1 and 3 to the power 10 times 3 times 10 to the power 4, which is 30,000, and each value is between minus 10,000 to plus 10,000. Okay, that is pretty much it. Let's remind ourselves of the approach we took in the last two problems. If you haven't seen the video, that's fine. So let's take an example. So I want to take an example where I think this is a good example, just a little bit bigger array. So let's say this is our array. In the example we took last time and last couple of problems, the approach we took in the last couple of problems was to run a source pointer and a destination pointer on the same array and just keep going. A source pointer always keeps going forward by 1, but destination pointer only moves when we have found a new element to be copied. To just explain that one more time, for example, let's say that we were doing this in a separate array and not the same array, then let's say that we have 1, 2, sorry, I'm just going to write blanks there, 1, 2, 3, 4 5 1 2 3 4 5 6 7, so 5 6 and 7 uh, elements in the result array, or 7 indices. Let's our destination index is at the first cell in result, or first element in result, and source is as first. Since it is our first 0 and it doesn't repeat more than twice, we have an element that we should put in result, so we'll do that and we'll move the destination pointer forward. Of course, we'll always move the source pointer forward. Same, we have a second 0 and one more 0 is allowed, so we do the same thing. We move source forward, we also move destination here. Now we have a different element and that's allowed, so we'll move the source and destination forward. Same with the second one, but once we move to source to the third one, since that is a third time it's repeating, we are going to not move that to, or not copy that to destination, and hence the destination pointer stays here but the source pointer moves forward. And then the next one, same thing, it's a fourth occurrence. Again, we are not going to copy that, so destination pointer stays where it was, but source moves forward to 2. 2 is a new element, so we copy that, move forward destination, source moves to 3, and similarly we do this. And like I said in the last two videos, even though this approach was demonstrated by showing in a different array, the same approach works even if destination pointer is just moving over the same array as the input array. And so that's the approach we are going to take. And the only thing is the condition under which we copy is now different than the last two problems. Okay, so what we are going to do is, now in this case, since we have to compare, or we have to count repetitions and then make, if we skip only if the count is greater than 2, we need a variable called count, or we can call it rep count as well, repetition count, or frequency. Actually, frequency is a good one, equal to 0. And or we can start the frequency to be 1, because if you want to just if you don't want to consider a special case of the first cell, because first cell doesn't have a previous, so yeah, we can do that. So let's do that. Actually, let's say this is actually 1, frequency is 1, and deleting some white space there, and our previous number or current number, doesn't matter, previous number equal to nums of 0, because that's what we are going to compare with. And if the current number is same as previous number, we are going to increment the frequency. And like I said, we need a dest index equal to 1, because we already looked at the first cell. And now we are going to run a for loop for source index equal to 1. We start with 1, like I said, because we already processed the first element. src index is less than nums dot length plus plus src index. Because src index always moves forward 1, a for loop on that is actually a very simple way of doing that. And here what we do is we say if if the nums of src index is equal to previous number, then we do a couple of things. We say, okay, frequency plus plus, so we found one more frequency, and after we do that, we will basically say if frequency is less or equal to 2, then we remember we copy into the destination index of nums. So test index equal to nums of src index, and we increment the dest index because we copied something. Also, when this is equal previous index, and nums of source index equal to previous num, and we incremented the frequency in the else of that, which means if the number is different, then we should actually do prev num equal to, actually we can always do prev num equal to the current num, because that should, we should just do that unconditionally. So we say prev num equal to nums of source index. Doesn't matter, we'll just override. That just saves us one if condition. And if frequency is less than 2, then I think this should be okay. Let me just think about it one more time. And yeah, we have to return how many numbers are there. So okay, so that is something we need to yeah, dest index actually. So dest index, like in previous cases, since it would have been incremented by 1, would actually have the correct count at the end of it. Let me just go over this. I went over this a little bit more quickly than other problems, so let me go over this one time on an example. Let's again take this example from here. Let's go over that. So let's say this is nums. So frequency will be initially v1, privnum will be equal to 0 because that's what nums of 0 is, dest index equal to 1, so dest index is pointing here. And we are going to start from here, source index, and go through the length of the array. If the number at the source index is same as priv number, it is, so we'll increment the frequency. Frequency started with 1, so frequency becomes 2. And since and then priv num equal to the current num, which will still stay 0 over it. 0 is overwritten by 0. Since frequency is lesser or equal to 2, we basically copy to the destination index and we increment the destination index. We go there. Now what has happened is destination index has also moved forward and source index has also moved forward because of the for loop. Now looking at 1, okay, so here is the thing, right? So we need to reset the frequency. Okay, so I already found a bug. So we do need an else, because if it is different, then we say frequency equal to 1. We found a new number, so we might as well put this statement in the if else part of the if condition. Okay, so I'm glad I checked it with an example. Yeah, if we basically see a new number, then our frequency starts at 1 again. And that's the difference. Yeah, so we saw a new number 1. Our frequency is starting at 1 again because of this one, and then previous is equal to 1 now, but frequency is less or equal to 2, so we are going to copy that, and again the dest will move forward and the source moves forward because of this part of the for loop. Now the second one, it is the same as the previous number, so increment of frequency to 2, but the frequency is still 2, less than or equal to 2, so we still copy that over, or copy over itself, and we increment the dest index. So again dest and source. Now for the first time we are going to skip, so we are at this third one here, both source and destination are there. This time again this is going to be true, frequency will be 3, but because frequency is more than 2, we are not going to execute these two lines, so dest stays here, which is good because we are going to override that with the next good number, but source moves forward. So I think this should work. Let me try to run this. Yeah, I have a typo there. Let me fix that. Okay, it says accepted. 2 cases, those are accepted. Okay, cool. I think there is not much else to say about this problem apart from what has been discussed in previous problems, which also we covered all of those things here as well. Hopefully that was helpful. See you guys next time.